Hospital Information System or HIS. HIS can be defined as a comprehensive, integrated information system designed to manage the administrative, financial, and clinical aspects of a hospital that enable better quality of patient care, reduce the time spent for clinical works, reduce the overall cost, increase the productivity, and importantly, providing the more reliable, correct, and regular data.
Benefits of integrated hospital information system: easy, fast, and convenient access to accurate patient information, readable, structured information, billing integrated with clinical management, and real-time financial reporting.
Module HIS, Person Management System or PMS, Patients Billing and Account Receivable or PBAR, Medical Records Office or MRO System, Clinical Information System or CIS, Laboratory Information System or LIS, Blood Bank Information System or PBIS, Pharmacy Information System or PHIS, Radiology Information System or RIS, Executive Information System or EIS, Forensic Information and Mortuary Management System or FIMMS. Patient Management System or PMS, manage patient activities, appointment or scheduling, registration, admission, discharge, transfer, and management of the disease.
Patients Billing and Account Receivable or PBAR. Manage patient billing and account receivable activities. Bill generation, bill management, bill payment, collection management, refund management, account reconciliation, and report generation.
Medical Record Office MRO System. Monitor, control, and manage medical record office activities such as file management and medical report.
Clinical Information System or CIS, to carry out the clinical activities, doctor documentation, nurse documentation, AMO documentation, clinical physician order entry, or CPO.
Laboratory Information System or LIS, receive orders and collect specimen, process orders, create testing work orders, lab equipment interface, actual testing, generate and transmit results, and generate management results.
Blood Bank Information System or BDIS. Blood donation management, blood procurement, blood safety, blood and blood component production, blood and blood component storage and distribution, blood transfusion management, and quality management.
Pharmacy Information System or PIS, Medical Order and Supply Management, Clinical Pharmacy Management and Manufacturing, Inventory Management.
Radiology Information System or RIS, receive subject and process order, examine management, transcribe, validate and distribute report, support generation of management report, support administration function.
Executive Information System or EIS, to retrieve selected report based on user criteria, to display selected report, to print reports where necessary, and to export graph or data to Excel or Word application.
Forensic Information and Mortuary Management System or FIMMS. Management of the deceased person, release of claimed or unclaimed bodies, storage of body and body parts, medico-legal and clinical autopsies.
Hospital Informatics System. Information Storage Technologies. The earliest storage devices that computers integrated were punch tapes and cards, in which data was indicated by punching a hole in a card or paper tape. When the first floppy diskette was introduced in 1970s, they were able to store 79K or 79,000 bytes of information, with each byte recording 8 bits, 1 or 0 of information. As the technology progressed, disks became smaller and held more information, by 1999 being able to hold 200 megabytes or of information on one disk.
Information storage technology. Hard disk drives were rapidly evolving during this era, and prices fell rapidly as the technology improved. Modern hard disk storage devices are able to hold a terabyte of storage in a package about 2.5 inches square. A terabyte is 1,000 gigabytes. Recent advances in memory chips have produced solid-state storages devices that are much faster than even the best hard disk and having no moving parts.
Information storage technologies. Health information technology evolved also in terms of the type of data being stored. Besides text information, audiovisual health data can likewise be stored in a computer server. A digital X-ray image is about 20 megabytes and a CT scan of the brain could reach 70 megabytes. Storing such large amount of data has been made simpler through storage technologies such as network-attached storage or NAS, cloud-based storages, and redundant array of independent disk array technologies. Even portable storage platforms have grown to such an extent that hundreds of radiographic images can be stored in an inexpensive external hard drive.
Tablet computing. The introduction of low-cost tablet computers and data-connected cell phones is rapidly changing the clinical healthcare arena. Where desktop computers have been the mainstay in the clinical environment, tablets are quickly taking over for some of the following reasons. These features make tablets the ideal device for bedside care because tablet computers will not hold large applications or store much data. Internally, they are best served with web-based software. Their major drawback is also their advantage. They can fit into a pocket and might be stolen if they are left unattended. Additionally, tablet computers can be used for real-time telemedicine consultation through built-in video conferencing. This work has been pioneered by Dr. James Moody of Offsite Care Incorporated. In the US, where rural hospitals are able to get consultations with specialists using iPad tablets.
Laptop computers. Laptops have also come down in price and can serve where a lot of typing is needed. Like tablets, laptops have a battery that will bridge over power outages and are very useful at nursing stations, admitting and discharge, lab, imaging, and other locations in the hospital environment. With the ability to install other software systems, laptops can be used to generate forms and track information that is not stored in the HIS or EHR system.
Wi-Fi routers with 3G failover. Where 3G or 4G data connections are available, Wi-Fi routers that support 3G and 4G can be installed on wards and at other strategic locations in the hospital. This system will switch to using the cell network when local internet connections have failed. In many locations, it will be necessary to provide external antennas to these routers in order to get adequate signal power to the router. This can also be accomplished with tablets that are 3G or 4G capable, but it is much more cost effective to use routers for this purpose.
Cell phone. Cell phones are becoming a critical device in the healthcare cloud computing revolution. Modern smartphones have all of the capabilities of tablet computers, although in a much smaller format. That being said, A well-designed web-based application can accomplish most of the same tasks as a tablet or desktop system. Physicians are finding smartphones to be very useful when assessing patient information at times when they are outside of the hospital environment. As this technology evolves, we will see even more applications that utilize the power of these portable devices.
Desktop computers. Desktop continue to drop in price and increase in storage capability and speed. In the clinical environment, desktops can be best served areas where portability is not an issue, as in admissions, lab, radiology, and other areas of the hospital. In addition, desktops can be linked to lab equipment and monitoring devices for automated data capture. The difficulty of sanitizing a desktop computer should be considered when deciding which device to deploy in any work environment.
3 types of networks. Peer-to-peer. In this network, computers connect to each other and share resources like printers, internet connections, and storage devices. This network typology is common in small office environment and home-based networks. The second is the local server. In a local server network, one or more computers serves as a central data storage system for a number of other computers with all of the computers at the same location and directly connected. The third is the cloud server. With a cloud server network, data storage is located on internet-connected servers and is accessible over any connection to the internet. This allows a wide variety of devices to be used to collect and disseminate information.
Networks. Each of these networks topologies has its advantages and disadvantages, but as internet connections have become more ubiquitous and faster, cloud-based systems for healthcare data have become more widespread for the following reasons.
Cloud servers can easily be mirrored in multiple locations to facilitate real-time backups of critical data. Cloud networks can be accessed from any internet-connected point, including over cell phone data connection. Cloud servers can share expensive security, climate control, power backup. Using cloud servers lowers the cost of local IT.
Thank you for watching.